Welcome to Lesson 1, Introduction to AI Labs and Sandboxes. In this lesson, we will start with an overview of AI Labs and Sandboxes, whether you're creating an AI lab at home or in the cloud. We will go over topics such as choosing the right hardware, so that means your GPUs, your CPUs, memory, and other system components. We will go over building or buying pre-built systems, and also what operating systems to choose, whether it's Linux, Mac OS, or Windows. We will go over the essential software for your AI experimentations, especially things like Python, Anaconda, Jupyter Notebooks, and many other frameworks. We will go over and introduce Hugging Face, Ollama. We will install Ollama to run AI models at home. And then we will go over many different Ollama integrations that you can use nowadays. We will explore the Ollama REST API and how to even use retrieval augmented generation pipelines in your lab at home and, of course, in the cloud as well. We will also explore tools like Rackflow. Let's get started. Since AI or artificial intelligence continues to advance, many organizations are asking their employees to do something with AI, to create some type of AI application and so on. Also, individuals would like to, upskill themselves and then, of course, increasingly leverage AI labs and sandboxes to experiment, to develop, and also to test any type of AI application or AI solutions before you put them into production. So these AI, quote unquote, AI labs or environments definitely provide some control spaces for you to test and learn, but they can also be implemented in two different ways. One, of course, at your home, so on-premise, and I'm going to give you throughout the course a lot of different guidance to how to implement this in your own home, right, or on-premise. And also you can take advantage of the cloud. There's a hybrid approach on where most organizations and most individuals are taking advantage of, which is basically including the integration of home-based labs or on-premise labs with cloud-based labs as well, so in a hybrid environment. So throughout the course, you're going to be learning a lot about how these environments are designed for developing and testing and deploying AI models. And they often include, of course, different types of hardware, software, and different tools that are needed to experiment with machine learning algorithms, generative AI models, and so on. You're going to be learning about tools like Ollama, the different types of hardware that you need for creating a home-based lab. And especially if you want to just take advantage of smaller language models that can now be run pretty much everywhere. And that is actually the concept of edge AI, basically running AI models at the edge, right? So at smaller environments, even in your laptop, right? And we're also going to be discussing the pros and cons of building or buying pre-built systems and the essential software that you need to have in those systems, as well as the operating system and many different libraries that you can implement to develop an AI application. Now, one of the advantages that you have whenever you're creating home-based labs is having full control of a complete oversight of your infrastructure, your data, your processes, and so on. And of course, convenient, right? You're not paying cloud provider or another provider for any type of infrastructure or for inference for that matter, even though inference costs and infrastructure costs are getting a little bit better, but it's still not cheap nowadays. Another advantage is that, of course, sensitive data will remain within the organization or within your premises and reduces the likelihood for some type of compliance problems or for you to worry about the provider actually, using that data for retraining their models and so on, even though most of the foundation model providers, including OpenAI and Anthropic, they provide capabilities or even legal features that basically guarantee that they will not use your data for training their model. So there's different options nowadays that you can take advantage from these foundation model providers, and especially in the enterprise version of it. Now, we talked about the advantages of home-based labs. There are a few challenges, right? So you do have to invest in the infrastructure. We're going to talk about building or buying pre-built systems, choosing the right hardware later in the course. But, doesn't also come cheap, right? It requires some initial capital for your GPUs, for your software licenses, and, many other things, even though you can take advantage of a lot of open source packages and libraries nowadays for developing AI applications. As a matter of fact, the majority of them are open source. Everything that I'm going to be including in this training is around free open source software. Another challenge with a home-based lab or on-premise lab is that you have to patch. But you also have to patch in the cloud. But this one, you actually have to keep up with regular updates for all your environment, your hardware, your software, your operating system, and so on. So, of course, in the cloud, that depending on the cloud provider, depending on the cloud model that you're using, that there's a shared responsibility in there, right? Smaller organizations may also lack the expertise. So if you're thinking about doing this for your company, and if you're in a small company, you may have the challenge that your peers, your coworkers may lack the expertise or at the end of the day, the budget to maintain cutting-edge labs as well. Now later, we're going to go over cloud-based AI labs and sandboxes and how to set up platforms like AWS. So in AWS, you have SageMaker, Bedrock. In Google Cloud, you have Google Vertex AI. Azure and Microsoft provide a lot of AI capabilities as well. Pretty much all the service providers nowadays provide some pretty robust capabilities to deploy AI applications. And we're going to learn about the pay-as-you-go pricing and also, how to do hybrid integration. So in many organizations and in many use cases, you're going to have a permutation of both. So a home-based lab or an on-premise lab and a deployment in the cloud. Perhaps, some of your data is at home and you do some of the processing in there, and some of the more elaborate functions for reasoning and many other things may be in the cloud, right? So it all varies depending on the use case and depending on the implementation. In the next section, we're going to talk about choosing the right hardware, your GPUs, your CPUs, your memory, and so on. In this section, we'll go over one of the most crucial decisions that you will make whenever you're building your lab, and that is choosing the right hardware components for your home AI infrastructure. So let's start with the backbone of any AI lab, and that is the GPUs, right? So the GPUs, or the graphical processing units, they are definitely the workhorse of any machine learning environment, right? So they're capable of performing thousands of parallel calculations simultaneously. So whenever you're selecting GPUs, you want to consider a few factors. The first thing is the compute capacity, which is measured in CUDA cores for NVIDIA cards or stream processors for AMD. And then the second is memory bandwidth and capacity, which is crucial for handling large neural networks and large LLMs. And then third, of course, is your budget, because top-tier GPUs can range from just a few thousands to a few tens of thousands of dollars. So in my case, as you see in the screen, I basically selected I'm using two different GeForce RTX NVIDIA 4090, systems, for this system that I'm going to be using here today. But as you know, with technology, Technology progresses so fast nowadays that I can assure you that by the time that you're watching this video, they're probably a lot more cost effective, I will say, or budget friendly and faster GPUs, right? Now, in my case, for this system, I also selected an AMD Ryzen. So let's move on to CPUs. Why they are not the star performers in any AI workload, they are still essential for data preprocessing and orchestration. So look for processors with high core counts and strong single-thread performance. The latest AMD or Intel processor are excellent choice. You can go up to many cores. In my case, of course, I'm just using the Ryzen AMD chips for this system. Now let's talk about memory or RAM. For RAM, the rule is pretty simple. The more, the better. So I will say start with at least 64 gigs of RAM for very small projects, but plan for 128 gigs or more if you're actually working with very large language models or computer vision applications. In my case, what I have in here is DDR5 memory, and I think that I have 196 gigs of RAM, 192 gigs of RAM or so. Later, we're going to go over and log into the system, and you will actually see the memory and the GPUs running. Now, for storage, you want a tiered approach. You configure your systems with fast NVMe SSDs for your operating systems and active databases and datasets as well that you will use. The large capacity SSDs for your model storage may be a good choice. And you can also use traditional hard drives for archival or backup purposes. Networking is often overlooked, but is crucial for many reasons, right? Consider investing in high-speed networking infrastructure. In my case, I have that ProArt motherboard that actually has a 10 gig Ethernet. And in many cases, actually, you want to either have it within the motherboard itself, or you can just buy an external network interface or NIC for you to actually use within your system. Another thing, of course, is cooling. So cooling is critical, but underestimated in many cases. So whenever you're running multiple GPUs, whenever you're running CPUs, you definitely have to actually consider your cooling solution, and those environments need to be robust. So I'm using liquid cooling for CPUs in here, and the other thing is that you make sure that you have a case or a chassis with adequate airflow. So, and also, of course, proper ambient temperature in your server room or in the room that you're going to be running your system. So again, for those of you that are building a system on a budget, you probably want to consider to have, a few of these components. Now, this system, of course, is not going to be cheap by any means, but definitely, with models now becoming better and the quantization techniques becoming better, the compression techniques becoming better, these smaller language models can now run even on a Mac, right? Or on smaller systems than mine in here. But again, this is actually one. I have two systems that are relatively similar, and it's because I want to experiment and I like to always test the latest models without having any hassle in here. Of course, in many cases, it's an overkill, and you can use the cloud, and you can host those in opinionated cloud environments like RunPod and many others. But in my case, actually, I do want to use some of my own data and run those models locally. Of course, we're going to be going over later into AWS Bedrock, Google Vertex, Azure AI Studio, and so on where you can also use those environments, probably in a little bit more cost-effective environment if you just want to learn about a specific model. But if you're thinking about running local databases, local data sets, your own data, and so on in a local environment, definitely you can build a system that will handle most entry-level to intermediate AI workloads effectively. Technology is advancing at a very rapid pace, as we know and we have witnessed in the last few years. So NVIDIA is always putting newer hardware and new solutions out there, along with many other companies. As a matter of fact, there's a lot of movement nowadays to move away even from GPUs to other platforms like ASICs that are going to be specifically designed for AI models and AI architectures. However, what you see in front of the screen is an example of NVIDIA's RTX power workstations, and they even have laptops. They also have a set of smaller devices that can definitely be run in your desk with Blackwell GPUs. This is something that they call Project Digits, and basically it has a pre-installed 128 gigs of RAM, and of course a Blackwell GPU in there that has 1 petaflop, which is pretty impressive for this environment. It also has 4 terabytes of SSD, so it is a pretty powerful, I would call it a small personal PC tailored for AI models and AI implementations. You already have the 5000 series of the RTX GPUs and new evolutions of Blackwell that are continuously being introduced in the market almost on a weekly basis nowadays. It's insane how technology is basically being democratized. It's democratizing access to high performance AI tools and AI components for you to develop your own applications. As a matter of fact, you have a plethora of open weight models, including the ones that NVIDIA released specifically for robotics and for things like self-driving cars. And a perfect example of that is a model called Cosmos, right? Or a series of models called Cosmos as well. So definitely, this is something that you're going to be seeing some advancements in robotics, in autonomous systems. And of course, this promises a very bright future ahead of us, and also a lot of security considerations that we have to now take with these autonomous systems. But however, going back to building a lab in here, you have many different options, whether it's buying a pre-built system like this, or just making something really simple. One of my recommendations is to get started. Even if you have a laptop with Apple Silicon or the M series chips, you can very easily install things like Ollama. It runs a lot of open weight and open source models. And as a matter of fact, later in this course, you're going to be learning about Ollama, different things that you can integrate with your personal PCs and desktop machines and laptops, and then have a hybrid approach where you're combining a home lab and cloud resources as well. So we're going to be covering all that later in the course. Now we're tackling a fundamental question that everybody asks themselves, and that is, should you build your own system or invest in a pre-built solution? So let's start with pre-built systems, right? There are many companies out there that offer workstations, desktops, and servers that are specifically designed for AI workloads. These systems come with many different advantages. First, they're tested and validated. The components are guaranteed to work together, and the systems, in some cases, are benchmarked for machine learning tasks. And there's a few companies that are now starting to specialize just in AI systems. Now, the challenge with that is that they are very, very expensive, right? Now, the other thing is pre-built systems do have a few additional drawbacks. Typically, they come with a premium. Of course, you pay a lot more than building your own system in many cases. And you're also limited to the configurations they offer, which may not perfectly match your need. Specifically, again, you are the owner of that lab, you're the owner of the scope, you're the one that actually wants to know what type of models you're going to be running, what type of learning you're going to be doing, or what type of things you're going to be putting, quote unquote, in production within your home environment, right? At the end of the day, in some cases, it's not so much of just learning, but also taking advantage of these newer models that can automate a lot of things, within your environment, right? Now, let's explore the DIY approach, which is building your systems from scratch. We just went over, a few notes related to hardware and what type of hardware you should be using, right? But one of the most obvious advantages in building your own system is, of course, cost savings, right? By introducing components directly, you can often build an equivalent system, or even better, for significantly less money. You also gain complete control over every single component choice and allows you to optimize your specific workloads. Now, building your own system also provides a really good knowledge, right? That you will understand your hardware intimately, making troubleshooting and upgrades easier, down the line. Plus, you can customize aspects like the cooling solutions, cable management, of course, the GPUs, the CPUs, the memory, and so on. But building isn't without any challenges. You need to research component compatibility, handle system integration, yourself, manage multiple warranty claims if issues arise, and of course, tackle your own troubleshooting. There are some other specific scenarios where each approach will shine, right? The pre-built systems make sense whenever you need systems up and running very quickly. You don't have any, worry about the cost, and you have limited technical expertise in-house to actually build a system, right? Now, build your own is often better whenever you're working on a tight budget or you need highly specific configurations and you actually have the technical expertise available. And at the end of the day, if you build any other PC for gaming and so on, it's basically exactly the same approach in here. In the next section, we're going to go over a few tips on choosing the operating system, whether you're going to be running this on Linux, Windows, or Mac OS. Now we're going into another decision that you have to make, which is choosing the right operating system for your AI development environment. So let's start with the most popular choice among the AI community, which is Linux. I personally use Linux at home in this system that you see in here, and many others, including many clusters running Proxmox and other environments for building labs for ethical hacking, for incident response, and so on, since I am mostly concentrated in cybersecurity. However, for my AI lab, definitely my choice is Linux. First, it's open source. It's definitely customizable. There are tons and tons of libraries for Linux that are related to machine learning and AI nowadays. And it allows you to optimize your system for specific workloads. The other thing is most AI frameworks and tools are developed within Linux in mind, and this makes it, the first platform to receive updates and new features in many cases. For the Linux distribution, I am just running Debian. You can run Ubuntu and many other, flavors out there, but I'm just running Debian to make it simple. Now, you can also, of course, use Windows. It is not the traditional choice for AI development. However, Windows has made many different strides with Windows subsystem for Linux or WSL2, right? This gives you access to a full Linux environment within the Windows native support. And also they have native GPU support for deep learning and many different integrations with other Windows tools. Now, Windows makes sense whenever you need to use Windows-specific software. Your team may be already familiar with the Windows ecosystem. And at the end of the day, most of the environments here, they actually run on top of Python, like libraries like Llama Index, LangChain, LangGraph, Langsmith, many others. Llama is another one that you're going to be learning later here today. So definitely, a lot of things are platform independent. Now, moving into Mac OS, I am actually running a Mac in here, and I'm SSH to that Linux system. So typically, my operating system for daily use is Mac OS, but I use that, of course, to connect to Linux systems within my environment here at my house. However, those systems nowadays with the M chips, so M1, M2, M3, M4 chips, they definitely offer better support for AI frameworks. And there's a lot of growing support for AI frameworks that are optimized for Apple Silicon. However, macOS has limitations for your AI workload. For example, you have limited GPU options, right? So you're restricted to Apple's integrated solutions. There are few deployment options in production environments and potential compatibility issues in some specialized AI tools. Now, my practical recommendation for most AI labs is to use Linux as your primary development and training platform. Again, Ubuntu, Debian, many other flavors of Linux are definitely a really good starting point. They also often offer wide community support and many different workloads and tools and related tools that are stable for those environments as well. In the next section, we're going to go over some basic or essential software to run, like Python, Anaconda, Jupyter Notebooks, and other frameworks. Let's go over some key tools and frameworks that are foundational in the world of AI. The first one is Python. Python is the bedrock of AI development. It has emerged as the de facto programming language for AI development because it's simple, and due to its simplicity, readability, and extensive ecosystem, you actually have a ton of libraries. And these libraries definitely facilitate tons of AI tasks, from data manipulation to complex neural network construction. A few notable libraries that not only assist now because of generative AI, but have existed for quite some time, especially for numerical operations and data analysis, is NumPy. And NumPy, of course, is for numerical operations, Pandas for data analysis, Matplotlib, and Seaborn for visualization. And then, of course, for machine learning and deep learning, libraries like TensorFlow, PyTorch, and Keras were widely used and continue to be widely used. Additionally, Hugging Face Transformers library, provides a lot of tools for working with large language models, which are very, very crucial for generative AI applications nowadays. Now, another comprehensive distribution of Python library or ecosystem that is not only for Python but also for R is called Anaconda. And Anaconda is basically specifically for data science and AI applications. It simplifies the package management and deployment, ensuring that you have a consistent and controlled environment for your projects. Anaconda comes with a powerful package manager that handles library dependencies and versioning, and then allows you to create isolated environments for different projects. And this isolation ensures that changes in one environment do not affect others, and then provides you with stability across your workflows. Another tool is Jupyter Notebooks. And nowadays, with Google Colab, it makes it even easier for you to exchange, example code, and then, of course, this tool is invaluable for data exploration and visualization and iterative development, right? So Jupyter Notebooks offer an interactive web-based environment where you can combine code and the execution of code with rich text, mathematics, plots, and media. And Jupyter Notebooks allow you to document your thought process alongside your code. Now, beyond Python, Anaconda, and Jupyter, there are several other frameworks and tools that are essential for building a robust AI lab, and of course, building an environment for you to experiment. Another one is called Kubeflow, and it's an open source platform that is designed to facilitate machine learning workflows on top of Kubernetes. So Kubeflow allows you to develop, to orchestrate, deploy, and run scalable and portable machine learning and AI workloads, and of course makes it easy for you to manage complex models and experiment. Another one is, of course, Hugging Face, the hub for open source or open weight AI models and tools. And particularly, it is known for its Transformers library. So it provides a lot of pre-trained models for natural language processing tasks and many other implementations. Now, later in the course, we will talk about a lot of libraries like LangChain, LangGraph, which is part of the LangChain ecosystem, Llama Index, or Llama to run open weight models locally within your environment, vector databases like ChromaDB, pgvector, Weaviate, Pinecone, MongoDB Vector, Atlas Search, and there's so many of them out there that I'm actually missing in here. So in the next segment, we will actually start covering the ecosystem of Hugging Face and additional libraries and tools that you can deploy within your lab. Now let's explore Hugging Face, a platform that has revolutionized how we develop, share, and deploy AI models. Whether you're just starting out or running a full-scale AI lab, understanding Hugging Face is essential in today's landscape. Let's start with the basics. What is Hugging Face, right? So think about it as the GitHub of AI. It's a platform where developers and researchers can share, discover, and collaborate on AI models and also datasets. But it's much more than just a repository. It's a complete ecosystem for AI development. You have thousands and thousands of models, datasets, spaces, and spaces basically are where you can showcase different applications, right? Now, at the heart of Hugging Face is a Transformers library. Now, let's look at a practical example. Let's say you need to build a system where you want to do visual question answering. You can just browse through the models, select multimodal, and click on visual question answering, and you see a whole bunch of open weight models. And open weight means that, of course, the source of the model and the weights are completely open to the public. So let's, for example, look at any of these models in here. Let's say the open face model here. If you go under files and versions, you see that you have information about the model itself, so the README, the configuration, a JSON file for the model itself, and you also see a whole bunch of files that start with the name model and then that end with the extension safe tensors. Now, safe tensors is a secure and efficient file format designed for storing tensors, which are basically multidimensional arrays used in deep learning and machine learning models. These were developed by Hugging Face, so safe tensors were developed by Hugging Face and addresses vulnerabilities in traditional formats like Pickle. And these safe tensors basically introduce security features that ensure that files cannot execute malicious code during loading. So unlike the Pickle files, safe tensors do not allow embedded Python code and then eliminates the risk of executing harmful scripts during deserialization. Outside of security, safe tensors enable faster model loading, and also the format uses serialization and compression to reduce the file size and optimize the storage and the transfer of models as well. The other cool thing is that safe tensors can be used across many different programming languages and frameworks like Python, and is cross-platform independent, right? I wanted to actually at least introduce you to the underlying information about the models, safe tensors, Hugging Face, and so on. And we're going to be actually going over this framework and this environment throughout the course. Let's go over one of my favorite platforms to run whenever we are building an AI lab, and that is Ollama. Ollama is a free open source platform that is designed to run LLMs or SLMs, small language models, locally on personal computers, in your home machine, and in the hardware that we have been discussing here today. It simplifies the process for not only running, but also downloading and installing LLMs and SLMs without relying on cloud-based platforms or requiring extensive technical expertise or data science background. Now, Ollama supports a very large number of models, including Llama, Mistral, Code Llama, Gemma, you see them in the screen here. And if you click on models, you will see the plethora of models that they actually support. And this list is growing on a daily basis. I mean, technology is moving so fast. And of course, these models are being introduced on a daily basis. And Ollama actually keeps up very, very, very quickly with newer models. You can also access their GitHub repository and get a lot of information about not only how to download and run Ollama and install it, and we're going to go over that in the next few minutes. However, different types of supported libraries and, of course, information about their models, as well as other information about how to create model files, how to create or copy models and pull the model from the repositories, copy a model, and so on. There are also a lot of community integrations that we're going to visit later in the course. We're going to be going over things like Open Web UI, chatbots that you can instantiate not only in a web GUI, but also in the terminal window as well. So again, the key features of Ollama is being able to run LLMs directly on your machine, and of course ensuring different benefits like privacy and avoiding cloud dependency and unnecessary costs in the cloud. And especially as models are becoming more accurate and even smaller models because of the quantization techniques and the compression techniques are enhancing on a daily basis nowadays, definitely Ollama offers a lot of benefits in here. I am running Ollama in this system. I call it Cerebro, but basically I can ask any questions, what is machine learning? And then of course you see how fast I get inference and, of course, a pretty detailed overview of what is machine learning. So very, very cool platform. You're going to be learning a lot about this platform here today. In the next section, we're going to go over how to install Ollama and how to run different models. Installing Ollama is so simple. You can just download it from the ollama.com website. So they have two ways that you can download it, either here in the bottom of the screen or, of course, right here on the top. However, this is available for macOS, Linux, and Windows. Since I'm running in a Mac, it defaults to macOS, and you can just download it for macOS by clicking on this button. For Windows, you can download the installation package right here. And then for Linux, you can just run this command. It's basically pulling the installation script from ollama.com and then piping that to the shell. If you go to their GitHub repository, they also have the same instructions right in their README. So for Mac OS X, they have the download link. For Windows, the same. And then, of course, the same command that you saw earlier. So the curl command. They also have installation instructions for manual install. So if you click on here, they go and walk you through the manual installation in Linux in case you want to customize a little bit of the installation as well. Now, if you go back, they also have an official Docker image in Docker Hub. So if you click on that, it will take you to Docker Hub. And you see here the Ollama Docker image. You can just do a Docker pull Ollama/Ollama and then run it within your system as well. So many different options for running and installing Ollama in an extremely simple way. Once you install Ollama, you can run the Ollama command. You can do Ollama run and then run a model, just like you're seeing in here, and or pull a model with the pull command. But if you want to actually run a model, and you don't have the model installed, it will pull it automatically for you. So in this case, I can just ask, what is machine learning again? And then, of course, I'm getting inference from that model. Now, if I click or press Control D, as in David, it goes back to the terminal window. And there are many other Ollama commands in here. So if I do -H, you see the different flags and commands that are within the environment. You have Ollama serve, Ollama create to create a model from a model file, Ollama show to show information about a model, and you can also do an Ollama list, just like this, and you see all the models that I have already downloaded in this system. So I have Llama 3.2 in there, so I can very easily get information about the actual model by just doing Ollama show and then Llama 3.2. And then in this case, you see the architecture, which is Llama base, of course. The number of parameters in this case is the 3.2 billion parameter version. The context length is 131,000, so 131K for context length. The embedded length you see in there, and the quantization techniques as well. So you may ask, what is this quantization Q4_K_M? Basically, this is a specific method that is used to reduce the memory and computational requirements for large language models. They represent their weights in lower precision, specifically in this case, 4-bit quantization. So the Q4_KM configuration is part of the K-type quantization methods that introduce in tools like, of course, Llama CPP and GGML and many others, right? So around precision and performance, basically at the end of the day, this is actually balancing accuracy and memory efficiency. So again, the benefits in here is to have models that are memory efficient. So models quantized with the Q4KM requires significantly less VRAM, like for example, around 7 gigs for some 7 billion parameters, right? And making them suitable for running on consumer grade GPUs or even CPUs in some cases. But I will definitely suggest for you to run this using GPUs. So again, there are several other commands, PS, for example, so you can do an Ollama PS to list running models, CP for copying a model, RM for removing a model, and then you also can get the help for any of the commands or the options in here. Now, if I run the Ollama PS command, you actually can see that the Omar model_32 is running, and at the end of the day, it's a copy of Llama 3.2. And you see the ID, the size in the hard drive for the SSD in my case. The processor in this case is actually running on top of GPU, and then additional information. So once again, Ollama is ideal for developers, for researchers, and any AI enthusiast who wants to leverage powerful LLMs or SLMs locally. And applications range from building an AI-powered tool to integrating LLMs into a specific software via APIs and so on. And later we're going to see many different examples on how to leverage Ollama and other tools in the ecosystem. Ollama's growing community has contributed to a variety of different integrations, different tools, and frameworks that extend the capabilities of Ollama across different platforms and different use cases. So in the GitHub repository for Ollama, which you see in the screen, there are many different community integrations, and I would like to highlight a few. And this list is growing by the minute, by the way, but I would like to highlight a few of them in here. The first one is actually Open Web UI. Open Web UI is a GUI that it can be run on top of Ollama to run many different LLMs or SLMs, small language models. And as a matter of fact, I actually already have it installed, but you can really easily install it in your system by just doing a pip install Open Web UI, just like you see in the screen. And then to run the web UI, you can just do Open Web UI serve, and then point your browser to your IP address. In this case, their example says localhost. I have it running on a separate system called Cerebro in my lab, but you will point your browser to port 8080, just like you see in the screen. I have this running already in my lab at the host called Cerebro, and you see that I'm pointing to port 8080, just like you see in the screen in there. And basically you have a ChatGPT-like GUI, and where you can ask any questions, you can select from different models. I have an uncensored model here that I was playing with, and as a matter of fact, I'm just gonna select here from the screen the pre-populated question of explain options trading. And I'm going to submit that. And as you see, you get some inference back. So the results are basically that options trading is similar to buying and selling stocks, but with some key differences, etc., etc., etc. So it is interacting with the uncensored model that I'm running on top of Ollama. Open Web UI also includes many different features that can take your implementation to the next level. So for example, you can edit the output or the inference that came in from the from the model. You can also save the output to a file. You can copy it as well, just like any other chatbot. It also has the ability for you to read aloud. It does have a very bad default voice, but you can also customize this for the text-to-speech feature, and I will show you that in a few minutes. But if you click on read aloud, again, I'm just going to show you a very quick example on how this sounds.
Options trading is similar to buying and selling stocks, but with some key differences. In options trading,
so it's definitely less than optimal there, but at least it actually does have the capability. And as a matter of fact, you can do a few tweaks in here. You can go into the admin panel, and it does have a lot of different settings. And I'm going to share with you how to get more familiar with all the different elements of Open Web UI, especially since they're actually adding more features almost on a monthly basis. However, you can create different users. You see that I actually have only one user in this implementation, only myself, and of course the role is admin, but you can add more users by just clicking on add user, and then you can also import multiple entries. You can also create different users by importing them from a CSV file, just like you see in the screen. We're not going to do that right now. There are many different features on how you can do evaluations. It's basically a leaderboard based on the models that you have installed in Olama, right? So these are all the models that I have currently installed within my system. You can also do function calling. You can import functions from a file, or you can export, of course, a function from there. You can configure a lot of different things within the settings. You can change the port for the web UI. You can go over different connections to other implementations or other Olama servers. I'm running everything in the same server, which is called Cerebro here, but you can actually point it to a different server, if you will. And then, of course, you can have the different models either enable or disable on a per user basis as well. So you can also do evaluations. And what are evaluations? Well, let's actually go to the documentation of Web UI. Basically, they have a really cool story on where they start the story here of meet Alex, a machine learning engineer with a mid-sized company, and Alex knows that there are numerous AI models out there, right? At the end of the day, this is a TLDR. Too many models, not all of them will fit your specific needs. So basically, you can create a leaderboard for evaluations. And Open Web UI definitely offers that evaluation system. And then you can actually use a thumbs up or thumbs down to evaluate the responses coming from those models, right? So again, if I go back to my implementation here, I can actually create an arena by selecting a model. And then I can even have visibility to public, to everybody in the implementation here, or a specific group, if you actually have configured any groups, but in my case, I don't. So let's change it back to private. And then in here, I actually can select a model. So I can compare Llama 3.2, is an older model in there, and I can compare that to Omar Uncensored 2 latest. And I save on that. Oops, I forgot about that. I'm going to put test 1, 2, 3, just to be simple here. And then, of course, now you have the ability for evaluating that model, and I'll show you that in a few minutes. You can also include different documents for a retrieval augmented generation implementation. And we're going to talk about retrieval augmented generation a little bit later in the course, but in very short, it's actually to provide additional context to the LLM using your own documents, including enabling Google Drive in here, to then reduce the likelihood of hallucinations or giving you bad information, because, of course, all these models have been pre-trained with some data sets that may not be relevant to whatever implementation you want to do. So, for example, if you want to actually go over your documents and provide that as context to then ask questions about those documents, then you can configure that in here and even have templates for you to follow along. But again, we're going to go over retrieval augmented generation later in the course, and we're also going to learn about another implementation called RagFlow. And there are many in the industry nowadays, since things are actually changing so fast. But this is a really cool feature within the Open Web UI implementation here. And again, it's all free, all open source, and pretty powerful. You can even select from different embedding models. And again, later we're going to go over embedding models, how to select them, what they are, how to use them, and so on. Now, moving along, you also have the ability to do web search. And basically, in this case, you can select from different search engines, including Google, DuckDuckGo, and many others that you see in the screening here. Now, remember that I was making fun of the audio that was in the read aloud or the text-to-speech feature for reading along the output of the model. Well, you can also change the audio settings, and not only you can use the default web UI voices, but you can also use other engines, including very popular tools like 11 Labs or even Azure AI Speech and OpenAI models as well. If you select 11 Labs, of course, you have to have an API key. The same thing for OpenAI. You need an API key for you to be able to interact with it. We're not going to do that in here. Of course, this is not like a course about Open Web UI, and we have a lot of additional integrations to cover. However, what I will definitely invite you to go is to their latest documentation on where they include information about all their features. You can do function calling, you can do a tool calling for creating agents within the environment, and many other customizations and different features that can take, again, this chatbot to the next level. Very impressive what they're doing with Open Web UI. Now let's go over a few additional community integrations that I would like to highlight. And by the way, I am posting information in my blog post related to many of these integrations and many of the other capabilities that we have. We're going to talk about Rackflow a little bit later. And if you go to becominghacker.org, you see a lot of these articles in here using AI Chat CLI tool, which by the way is one of the integrations that we're going to talk about later. And Enchanted is another one, Rackflow, and so on. And if you click on them, you actually can go over all the different implementations, examples, and how I actually have tested them, and so on. But we're going to talk about a few of them in the next few seconds. So again, the list is significantly long, and this is growing by the minute. And this is a perfect example of why technology, and especially in the realm of AI, is advancing at an unprecedented pace. And then given this, of course, you will expect that this list will continue to grow significantly. But I want to actually highlight a couple of other ones in here. As a matter of fact, I already opened using the AI chat tool, or CLI tool called AI Chat, as you see in the screen here. And it's one of the integrations with Ollama. It's really powerful. As a matter of fact, you can do things like this. You can cat a file, so you can open a file and then pipe it to AI Chat. And then basically you can have a prompt. And in this case is a JSON file, and you're basically saying, convert that to YAML. And it actually does it for you. Or you can do AI Chat and then echo server in Node, JS. And of course, it can actually create a JavaScript for you to have a Node.js server, right? I mean, this is pretty powerful. You see another example here of translator. I translate that from, I believe, Chinese to English. And of course, you got the hello world. And apparently that's what it reads in there. I don't know Chinese, but very powerful. And so I have a write-up about everything that you can do with that integration or that utility called AI Chat and how to install it. You can install it with Rust using the Cargo feature set, or the Cargo package manager, or in a Homebrew or Linux Brew environment. You can do brew install AI Chat, and of course I have many other examples in here. Since I am in my blog, I would like to go over yet another integration that is pretty popular, and in this case is an open source application that is designed for the Apple ecosystem. So you have Mac OS, iOS, and Vision OS as well. And in this case, you can use this in combination with Ollama to, of course, run language models locally and integrate across all Apple's ecosystem. I have a video that actually explains that, and it has a demonstration. I am not going to, of course, play that video, but this one specifically allows you to, or demonstrates how you can integrate with the Vision capability from Apple. So the Apple Vision Pro capabilities using models from Ollama as well. So again, the list is pretty long. In the next lesson, we will explore the OLAMA REST API, and we're going to go over the details on how to take advantage of the application programming interface of OLAMA. OLAMA has an API that is extremely versatile, and you can access the documentation in their GitHub repository. They have plenty of different operations and methods that are available for interacting with OLAMA programmatically, from generating chat completions to creating a model, listing local models, and many other operations. And they have all those examples in here using a curl. So as you see, I have OLAMA running, and at the end of the day, I'm actually using curl to interact with the API on port 11434. And just like in the documentation, is very well explained, you can do many different operations, as I mentioned to you earlier. And in this case, I'm actually just doing a PS to list all the models that were running at that given time. And in this case, QWQ latest is the model that was actually running. And as a matter of fact, I actually killed it right before I took this screenshot. So you can also list all the different models that are available locally in OLAMA by using the tags method. And I'm going to copy and paste this to my command prompt. I'm going to just type it. And you see that, of course, JSON, the very, very ugly JSON output, but this is, of course, meant to be read by a machine. It's a machine readable output, not by a human. But you see that actually you're getting information about all the different models that are installed. Of course, if I actually do an OLAMA ls within the environment, you actually see all the models, but programmatically, you can interact with the API for many, many different operations. Again, to do chat completions, to list of the models that are running, delete models, push models, create new ones, even create embeddings using the API. So if I scroll up and I click here in generate embeddings, you see that there is an ability or a method for generating embeddings from an embedding model. So there's an example here of using all mini LM as an embedding model, and then basically the input is y is the sky blue, and of course you actually get the vector embeddings down below. So a very powerful way to interact programmatically with OLAMA, and many integrations, many tools that integrate with OLAMA, of course, take advantage of this API. Generative AI models definitely are revolutionizing pretty much everything, nowadays. And you probably already know that these models often face many limitations. And examples of those limitations are generating inaccurate information or what we call hallucinations. So retrieval augmented generation, or RAG, is a framework that is designed to address those challenges. And basically, what you do is you integrate external knowledge bases and knowledge sources, documents, and so on to the generative AI process. In other words, actually putting these as vector embeddings and then sending that as additional context with your prompt. And many other capabilities. Is not only about only documents, but you can also do function calling, tool calling, and many other techniques that we're gonna go over later in the course to then provide additional context to the LLM to give you a better answer, right? So again, RAG is a technique that combines the generative capabilities of LLMs with the precision of information, retrieval systems, and you can interact with things like vector databases. So in this example that you see in the screen, basically I have my own data. And in this case, for this example, I have security best practices, security advisories, CVE, so vulnerability information, CWE, which is the root cause of the vulnerabilities, and so on. And basically, I'm using an embedding model. And then optionally, I can basically convert those documents from text or PDFs or pictures and so on into vector embedding. So in other words, convert them into numbers. And then you can put that into a vector database. And whenever a user asks a question, whether it's through a chatbot or through an agent and so on, then of course it will provide that question or that prompt. You can do semantic search and then retrieve, thus the word R or the letter R for retrieval augmented generation. And then you rank those results. There's many mechanisms to do that, and we'll cover that later in the course. And then we provide that additional context to the LLM to hopefully get you a better answer. The other cool thing is, of course, that RAG-enabled models retrieve specific authoritative information from external sources like databases, live feeds, API calls from another, or information from another application, and so on. This is also a process that we call grounding in data sciences. Basically, it uses all these processes to generate a grounded response. So if I was going to summarize on how RAG works, it basically operates in two main phases. Basically, the ingestion of documents, so the document loading, and then of course the storing of those documents in a vector database and so on, and then the retrieval of those documents and the semantic search, and of course the generation of the content, or the task that you gave the LLM or the AI model. There are many different use cases for RAG, right? You can use RAG for customer support chatbots, which are powered by different product manuals, FAQs, and support documents to provide assistance to, of course, a human in that case, or content creation. Writers can actually use RAG to generate articles. You see this a lot in the news nowadays. Healthcare, you can retrieve accurate medical documents to provide medical advice by referencing updated clinical guidelines or even patient records in some cases. In finance, you can actually do a lot of real-time insights. Basically, you can retrieve information, live information about stock prices, market trends, regulatory updates, many other things that can absolutely be provided as additional context to the LLM to give you a better answer. So that is retrieval augmented generation. Throughout the course, you're going to be seeing a lot of different tools that you can integrate within your lab and within your sandbox environment to start playing with this, including different vector databases like ChromaDB, pgvector, MongoDB has a vector search in their Atlas implementation, and Weaviate, and there are many, many others out there as well. Earlier in the course, we were covering the different OLAMA integrations and many different community efforts that have integrated with OLAMA and other implementations as well. But in this case, I kind of tabled, or I postponed going over one of the integrations, which was called RAGflow. And RAGflow is an open source retrieval augmented generation. And we just cover what retrieval augmented generation is, or RAG. And it's an environment, an engine that will actually integrate with OLAMA. And of course, you can run different large language models or small language models in there. It allows you to take advantage of many different features to create RAG implementations and also to create agents. So what you're seeing in the screen is a blog post that I wrote that I introduced RAGflow. And in there, I actually have links to their developer documentation, which I have open in a new tab in here for later to review. And then I also include their architectural components in here. If I wanted to summarize the architectural components, I will divide them into these categories: data ingestion and processing. So of course, accepting different data formats, including PDFs, Word documents, web pages. You can actually search the web and export that as HTML documents, and then introduce that into the knowledge base. And that's the second component, knowledge base management, which is basically data that is stored and transformed into vector embeddings and stored in vector databases. So then you can retrieve that data. And then, of course, you can have different advanced indexing and chunking methods for enhancing the retrieval accuracy from those vector databases. And all this functionality is built in within this ecosystem. And then, of course, you have the retrieval method to actually retrieve and search the knowledge base to identify the relevant information to then provide that to the actual language model. So that's the language model integration here. So to provide additional context to the language model to reduce the likelihood of hallucinations and then give you a better response. And that is the next phase. The other cool thing is that the system will actually produce answers that are also including citations. So basically providing traceability and transparency to the original data sources. And then in that case, you can provide additional citations for authoritative content that you have given the system, and then the specific sections of those documents that you created the vector embeddings from, right? So this is really, really powerful, very similar to what you see in tools like Perplexity and many, many other retrieval augmented generation implementations in the industry. The other cool thing that it actually has is a user interface and an API. So everything that is in the user interface is also in the API within their environment. Now you can deploy this locally. This is only the hardware requirements for Rackflow. Of course, for Ollama, depends on the model that you're going to be using. There are different requirements and different hardware components that you may have to invest a little bit of money. And we talked about that earlier in the course. Now, one of the easiest way to deploy Rackflow is by using Docker. And in the same write-up, I include information on how to use Docker Compose. And at the end of the day, you clone their GitHub repository. And again, all this is in the link that I'm showing here in becomingahacker.org in my blog post. Once you clone the repository, you change the directory. And in that case, in here, I just perform or executed the Docker Compose command that you saw here in the screen, right? So in the write-up. Once you actually have that, you basically just navigate to the IP address of your system using your web browser, right? And in there, you can select from different model providers. Of course, in this case, we're using Ollama, but you can integrate with OpenAI, with Bedrock in AWS, Anthropic, Azure, and the list goes on, right? So you can run models from Hugging Face and many, many other implementations that they have. It's pretty powerful. Now, to configure an LLM, in this case, for Ollama, I'm actually using the model type of chat, and you can integrate this with embeddings. And as a matter of fact, you need an embedding model in order for you to actually convert your data and your knowledge bases into vector embeddings to then provide that information to the LLM to do something with it, right? Or to store it into a vector database so you can actually do the retrieval, right? So the R of a retrieval augmented generation, or the RAG. Now, in this case, I'm actually just using Llama 3.2 just because of convenient access to that model at the time of recording. And then I'm pasting my IP address, or I'm putting my IP address in here, 192.168.10.88 on port 11434, which is where the API for Ollama resides, right? And then in this case, you can actually put an API key if you have locally deployed models, then you can ignore that, running Olama. But if you actually have another model or another model provider, then you need an API key, for example, OpenAI and so on. But in this case, we're actually running everything locally. And basically, I'm putting 16,000 max tokens. It depends on the model, depends on the implementation, and also the compute power. The max tokens is something that you need to refer to depending on the model capacity as well, right? So Llama 3.2 has a different limitations for maximum tokens than, let's say, O1 or O3 from OpenAI. It also allows you to configure if the model supports vision, because you can integrate this with the vision capabilities of some models. In this case, I am not including a vision. Of course, you can click on OK and then move to the next step. And everything is actually documented step by step. I'm not going to read the page here for you, but I want to show you something that is extremely powerful here. And one of them is, of course, for you to do evaluations of your implementations. I basically created a knowledge base called super secret data, right? And in that case, I basically had the output of the SQL injection or SQL injection prevention cheat sheet from OWASP. I put it into a text file and I uploaded it to a knowledge base. And at the end of the day, behind the scenes, what it's doing is putting it into a vector database. Then in this section, I basically did a test for retrieval. And you can play with a lot of different metrics, including similarities, thresholds, keyword similarity weights, and many others, right? So you can also use a re-rank model if your implementation has it available. But in this case, you actually see that on the right, all the chunks of the documents that were retrieved by the implementation. Let me make this a little bit bigger so you can see. So all those are the chunks of the documents, in this case only one, that I actually uploaded here. And then that can be used as additional context for then sending the information to the LLM to get a better answer. You can also create assistants, and basically you have the ability to create an assistant. In this case, I just call it a web application security expert. You can put a description. You can even put an avatar. And in this case, you can even set an opener. And in my case, I just put, "Hi, Omar. I am your web application security assistant. What can I do for you?" Right? So that will be what you will see in the input section for the prompt from the user, right? And you can, of course, be as creative as you want in there. You can disable to show the quote or not. And then you can even enable text-to-speech. And in my case, I'm actually selecting the knowledge base that I previously created called Super Secret Data, right? Another cool feature of this implementation in Rackflow is that allows you to do different system prompts for, of course, your assistant. And in this case, the system prompt that I configure says that you are a web application security expert specializing in identifying and mitigating vulnerabilities within web applications. Your responsibilities include blah, 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 different vulnerabilities. So, of course, the more prescriptive that you are, the better results that you will get from the AI model. And later in the course, you're going to see many other examples of prompt engineering techniques for system prompts and assistants. In this section, you can also see that you can play with different similarity thresholds, keyword similarity weights, the number of documents or the top end for the chunks for the documents that you're going to be retrieving to then send to the LLM. Also, you can configure multi-turn optimization, selecting re-ranking models, and basically re-ranking is the technique that you can deploy within your retrieval augmented generation environment for the retrieval aspect of the semantic search. And once you get the chunks of information from a vector database or for multiple vector databases, you can re-rank those results to then send the most relevant data to the LLM to, of course, then get a better answer. Now, all these I have it documented within the write-up in here, including the top-end results, the multi-turn optimization, right? Basically, multi-turn conversations is for follow-up questions and contextual dialogue capabilities within the implementation. So all this, again, is all documented here. But one thing that I want to highlight is that you can also create AI agents. It introduces the methodology and the capability for you to create agents with very low code or no code requirements. So basically it's featuring low code, no code workflow editors, and then a graph-based task implementation. So in other words, you can create an agent. So they even have examples of different agents that you can select from. But in this case, you can basically drag and drop different types of operations, whether it's retrieving information from a database, interacting with another application using their API, and then follow-up questions, reasoning, and many others. So this is extremely powerful for anybody that is actually trying to create an agentic implementation with LLMs, and of course, integrating this with Ollama. So once again, all the links for their documentation and their detailed explanations on how to create agents in a very, very step-by-step way is all linked in my article, in my blog post. So take advantage of that. Now, in the next lesson, we're going to be going over cloud-based AI labs and sandboxes, the advantages and disadvantages of running some of these labs in the cloud. You're also going to be learning about how to deploy Ollama using Terraform in AWS and many other things. You're going to be learning also about Amazon Bedrock, SageMaker, Google Vertex AI, and Microsoft AI Studio.